Question 3. A curve has equation y equals 2x cubed, take away 2x squared, take away 2x plus 8. So the same curve as the previous question. Find the range of values of x for which y is increasing. Write your answer in set notation. So I'm going to highlight again our key knowledge. So we're given the curve again. We're given that we want to find the range of values of x and that y is increasing. And our instruction is to write our answer in set notation. Okay, so let's first of all try and translate the words into maths. So range of values, that means we're going to need inequalities. Yeah, range of values suggests that there's going to be more than one answer, and the fact it said the word range means inequalities are going to be involved. And y is increasing. Well, if a function or curve, which y is, if that's increasing, then our key knowledge for that, so here's our key knowledge, means our gradient, so our dy by dx, our rate of change, is positive. Yeah, and set notation, our key knowledge for that, set notation looks like curly brackets, x, colon, and then what our restriction of x is. So something like x is bigger than a number, for example, or less than a number. And our key knowledge also means we've got the kind of U shape, the union, which kind of means the word or, and we have the N shape, which means intersection, which kind of means and. Okay, so now is the algebra step. So we've converted the problem into maths now. Now it's just down to solving it. So we know that dy by dx has to be bigger than 0. That's what we want. And in the previous part, we worked out what dy by dx is. It was 6x squared minus 4x minus 2 is bigger than 0. So what we have to do to solve an inequality is, remember, our first step is we want to get what's called the critical values. So that's when our two sides of the inequality are actually equal. And the easiest way to see this is always by drawing these as graphs. So here's my axes. So I'm going to solve this equation to find out what the roots of my quadratic is. So I could use my calculator, I could complete the square, I could do it however I want. It's up to you. I'm just going to quickly divide both sides by 2 to get 3x squared minus 2x minus 1 is 0. And I can factorize that to get 3x plus 1, x minus 1. So I get that my critical values are x's minus a third by making the first bracket equal to 0, or x equals 1 by making the second bracket equal to 0. So if I plot my quadratic, and again you could sketch this on your calculator. So here's my quadratic, and I'm going to do this in green. So that's my quadratic plotted there. I'm also going to, let me just grab a different color. I'll do this side of the equation in pink. So if I draw the graph y equals 0, I just get the x-axis. And I've got my critical values. So that splits the graph into 3 sections. I have, I'm running out of different colors I can use. I've got section 1, section 2, section 3. So my x-axis, my values for x have been split into 3, and I want the sections where the green graph are bigger than the pink graph. By looking at the inequality, it says green is bigger than pink. Well, if I'm on this part of the x-axis, the green is up here, the pink's down here. So this section works. So I'm going to put a tick for this section. If I'm in the middle, then the pink is bigger than the green. So I don't want this section because I want my green to be bigger than pink. And if I look at the outside section, yeah, the green's up here, the pink's down here, so green is bigger again. So I'm going to put a tick there. So there's two sections I want. So I want the section where x is less than minus a third, or I want the section where x is bigger than 1. So that's how I'd write it using inequalities. To turn it into set notation, I have my curly brackets. I tell my curly brackets what my variable is. So x, the dots mean such that, so what's the restriction on x? X has to be less than minus a third. Close my curly brackets. The word or changes to a union, so that's kind of like the U shape. And the same thing for the other inequality, x such that x is bigger than 1. Okay, and let's see where the marks come from for this one. So the marks come from using your key knowledge to get that my derivative is bigger than 0. So making your answer to the previous part bigger than 0 and attempting to solve it is your first mark. Your second mark is an answer mark, so you must get these two answers for the second mark. You must get minus a third and 1. The third mark comes from, so you might have got the wrong answers, however you still should have got 2 roots. So your third mark comes from choosing the outside roots. So spotting that bigger than 0 leads to 2 roots in this case, 2 sections in this case. So by having 2 different regions gets you the third mark. So like I said, it might not have been the numbers minus third and 1, but for you saying x is less than a number or x is bigger than a number gets you your third mark, and your final mark obviously is by getting the right answer.